Hi, my name is Vijender Reddy. In this video, I will explain a similarity based trust model to mitigate bad-mouthing attacks in Internet of Things. So before going into the trust model, first I will explain about what is fixed networks and dark networks, and then I will explain what is Internet of Things. So fixed internet networks are one fixed node will be there, and all mobile nodes are connected to this fixed node. So for example, if you take GSM network, this has a fixed infrastructure because each mobile node connects to fixed node. So this is called fixed infrastructure. That means if one mobile node A wants to communicate with C, it first communicates with the fixed network, that is tower, and then from tower to C. Even though if it wants to connect to B, then also it needs to connect to tower and from tower to B. So this is called fixed infrastructure network. And whereas for ad hoc networks, there is no fixed network. For example, if we have A, B, C, D nodes are there, so there is no fixed infrastructure. So A, B directly communicate with each other. If A wants to communicate with C, it directly communicate with C. But the main thing is it should have sufficient radio range to communicate with C. So there are three different variants of ad hoc networks. One is MANET and wireless sensor networks and wireless mesh networks. So apart from this, some other also there, but these are the major ad hoc networks. So if you see the MANETs, this is all mobile nodes or laptops are connected to each other, and source and destination will be there and to communicate with each other, and each node acts as a router as well as a node. Whereas if you come to sensor network, all sensor nodes will be there. So it senses the environment, and each and every sensor node can sense the environment and also forwards the sensing information to the base station. So this is sensor network. Whereas mesh network, it is a mesh router, so only forwards the nodes, forwards the packets, and this mesh network connected to any MANET or wireless sensor network nodes. So these mesh routers are high-end routers compared to the MANET devices and sensor devices. So coming to the Internet of Things. So Internet of Things also contains sensor network. It also contains MANET and mesh network, and everything will be there. So if you see the normal IoT, so a device that we'll call it a thing is a device, and it is connected to internet, and from anywhere in the world you can control or sense or send information or receive information from the thing from anywhere in the world, because it is connected to internet. So this is called Internet of Things. So all the things are connected to internet, and from anywhere in the world you can control or you can receive or you can send information to those things. So this is called as the Internet of Things. So there are different variants of networks will be there. For example, you have a mesh network here, and sensor nodes are here, that means things are here. Things are connected to mesh network and mesh network connected to internet. So like that. But either directly or indirectly, the thing should be connected to the internet. This is called the Internet of Things, which we call as IoT. So the thing in IoT is a networked embedded computer. It's a small computer, you can say, because it has a computing capability, very little computing capability, and it has a wireless communication and connected to internet. Not always directly, through indirectly. So things are independent to each other, because if you say this thing is dead and other thing, there is no dependency on things. But if you want to a thing wants to send information to the some destination or some other cloud or something like that, it has to rely on some other things. So the mutual cooperation between the nodes are required in the Internet of Things. So the context is a network may contain selfish or malicious nodes. So selfish nodes are it doesn't harm the network, but it wants to protect his resources. whereas malicious things are harms the network. So there is a small difference between selfish and malicious things. So assessment of things behavior is required to identify whether thing is legitimate or malicious node. So it's a continuous assessment is required, and there are two mechanisms to assess this behavior. One is cryptography based mechanism, and another one is the trust based mechanism. Cryptography based security mechanisms are not dynamic. So that means if you see the authentication and so if you enter the password, so you enter into the system network, so that means you are a legitimate node. So once you enter into the network, you can do whatever operations you want. If you do malicious activity also, but still this will not identify because it's not dynamic, whereas in trust mechanisms are dynamic. That means even though you enter into the system, it still continuously evaluates the behavior. So that's why trust mechanism is, are dynamic. So it is used to mitigate internal attacks, and these are generally distributed computations. So this is a small scenario as previously explained. So these sensor nodes, we call it things, are connected to the devices where it has some UHF modem or something. So things will sense the environment, and it sends these environments to the cloud through some path. So all these nodes between these two should mutually cooperate with each other, so that the sensor node sends the information to the cloud. So before going to the trust models, first I will explain what is trust. So trust is a set of relations between two entities. For example, E1, E2 are two entities. So the relationship between these two, it gives the trust value, and it is a belief or a confidence. It has some value. So based on the value, the belief or confidence will appear on the other node or thing. So how this will happen is, if you have three persons here, A, B, C. A wants to communicate some information to C, but A wants to pass to information to C. But the problem is A doesn't have direct access to C. So what he will do is he shares some information to the B. So that information B has to forward it to the C. So now the question is whether so if you see, this is I1 and this is I2. So now the question is the information whatever passed is correct or it is wrong, and even though it is something more difference than whatever earlier communicated between A and B. So before that, if A wants to communicate with C, so A will tell information to the B. So but A wants to know whether B forwards to information to C or not. So that gives a confidence value or belief value, so that the A assumes that B definitely forwards the information to C. So this gives a trust. So based on the trust value on B at A, trust value on B at A, if it is more, then A trusts on B. So he immediately tells the information. So A believes that B forwards the information to C. So if trust value is less, for example, normally trust value is in between 0 to 1. So if it is 1, it's a legitimate node, and 0 it's a malicious node. If it is 1, A believes B. If it is 0, A doesn't believe B, so he will not give any information to the B. So this gives this entire operation depends on the trust value. So this trust will build up based on the past interaction, previous interactions, like human being, how they will compute the trust value on other persons. So similar kind of a thing in Internet of Things also, we need to compute the trust value. So these are the trust properties. Trust is dynamic, as earlier said. So each and every node continuously evaluates the node's behavior. So its trust value will change continuously. So that's why it's dynamic. Trust is not necessarily transitive. So it's not transitive. So for example, A trusts B and B trusts C. That doesn't mean that A trusts C completely. So it is something different. So that's why it's not a transitive, and it's not a symmetric also, because if A trusts B, that doesn't mean that B trusts A. And trust is context dependent, and based on the context only the trust value will be there. So for example, if you have a car mechanic, you can trust on him for car repairs or anything, but you cannot trust that much on movie reviews or something else. So there are two types of trust computations. One is distributed trust computation, and another one is centralized trust computation. In distributed trust computations, there are three mechanisms: direct, recommendations, and hybrid. So direct trust will be computed based on the direct interaction. So A and B has direct interaction. Based on that, direct trust will be computed. So indirect trust will be computed based on the recommendations. So here Z has trust value on B. So that value recommends to the B that Z has some trust like that. So from that recommendations, A computes the indirect trust. So hybrid trust will be direct trust and indirect trust will be fused with each other. So the final trust will be called as a hybrid trust computation. In centralized trust computation, there is a trust agent will be there. So that is a central server. Each and every node in the network send the trust information to the trust agent, and trust agent computes the trust values of each and every node and broadcasts to the network, so that each and every node has a trust value on all other nodes in the network. So it is completely global perspective, but it is a local perspective. So if you see the recommendations, how a node forwards the recommendations. Here you see a small network P, Z, Q, A, B, C. These all are nodes here. So how P sends a recommendation to Z is, P has a neighbor A, B, C, and Q. So it has all trust values on these nodes. So all these trust values, for example, P has a node A, it has 0.84 and B 0.87. So all these things will put as a recommendation, and this will be forwarded to Z. So when Z receives, Z knows that whatever P trust values on these nodes, it is there. Similarly, Q also send trust values as recommendations to Z. So now Z has recommendations on A from P and Q. So here it is 0.84 and here it is 0.82. So once it got all the information, it fuses the information, and finally it gets the indirect trust value. So this is how the indirect trust will be computed. These are popular attacks. If you see a network here, these D and I are the malicious nodes, and remaining all are the legitimate nodes in the network. The first attack, if you see, packet dropping or modification attack. So what malicious node will do is, whatever packet it receives, it just drops it. So this will call it as a black hole attack, whereas for a gray hole attack, some packets it will transmit and some packets it will drop. So this is called a gray hole attack. And similarly, wormhole attack is, it forms a tunnel between two malicious nodes, and whatever root packet it receives, it says that there is only one hop distance between these two nodes. So that's why this will become a shortest path. So if you see the shortest path algorithm, so whatever shortest path is, so only that data packets will go into that shortest path. So that means all these nodes will send information to this tunnel only. So that means through this malicious nodes only. Once malicious node receives the information, it analyzes the traffic, or it go into the packet and see what the content is, or it modifies the content, something. It do some malicious activity on the packets. This is called as a wormhole attack. And if you see the Sybil attack here, Sybil attack is, the node identity will be different for different nodes. Here I is a malicious node. It shows identity as 1 to J, and 2 to H, and 3 to G. This is called a Sybil attack. A newcomer attack is like, this malicious node go outside the network and again comes back to as a new node. So when it comes as a new node, so all the past interactions will go out. So that's why this go out and come again as a new node, and it gains the trust and again do some malicious activity. Trust value will be reduced, and again it goes outside, and again comes inside. Again the trust value will be the neutral value. So again it do some malicious activity. So this is called as a newcomer attack. and all these things are the basic attacks on the network, and these three are the bad-mouthing attacks, on-off attacks, and collision attacks are on the trust model itself. So bad-mouthing attack is like node sends a bad recommendations on legitimate node. For example, if C is a legitimate node, so the trust value here it has a 0.9, but since B is a malicious node, what it will do is it sends a trust value of C is 0.1 only as a recommendation. So this is called as a bad-mouthing attack. On-off attack is like if node initially works as a good node, so the trust value will be increased, so it's a good node, and trust value will increase. So once service is over in the network and it acts as a bad node, so the trust value will be decreased. And again, if it wants to some service, so again it acts as a good node, so the trust value increases. So it uses the service to the network, again it reduces do the malicious activity, and the trust value will decrease. This is called of the on-off attack. Like means it is a good bad behavior. It's a ping pong kind of a thing that oscillates between good and bad behavior of a node. And collision attack is like suppose 3 nodes or more than one node forms a group. It's a malicious group. So whatever nodes within this group will send as a high values, high recommendation to neighbor, and outside whatever legitimate nodes are there that sends as a low value. So here D sends even though C is a malicious node, it sends C is 0.9. For E it will send as a 0.1 or 2 something because it's a legitimate node. So this is called as a collision attack. It's a very complex attack to identify compared to the other attacks. So the proposed trust mechanism computes the direct trust value and indirect trust value. So direct trust is computed based on the packet forwarding behavior. So here the protocol to context to compute the trust is packet forwarding behavior, and indirect trust is computed based on the weighted average mechanism. Here the main thing is we proposed a novel similarity mechanism to compute the recommendation credibility. So this is the direct trust computation. How we will compute the direct trust is, so for example J1 wants to send information to J2. So what it will do is it sends some packets to A, so that we will say is the packet sent, and once packet is sent to A, so A forwards the packets to J2. So that we will call it as a forward. So the packet forwarding behavior it will be like number of packets forwarded by number of packets sent. This is called as a direct trust value. So here what we will do is S is the number of packets sent. How we will calculate is number of packets forwarded plus number of packets dropped. So this is called as a number of packets sent. So here the same thing is happening here. So number of packets forwarded by number of packets sent. So this is the direct trust algorithm. So whenever packet is sent, so we increment the number of packets sent to 1 plus 1, and if packet is forwarded, so packet is forwarded plus 1. So how it will be is A sent packet to B and B forward the packet to C. So this is forwarded and this is sent. So but how A knows that B forwarded the packet or not? So what it will do is first A stores the sent packet as some packet P1 if you assume. So now P1 is at B, so P1 B forwards the P1. So it is since it is a broadcast medium, wireless broadcast medium, so what will happen is A listens the B's communication. So P1 is received to the A also. So once A receives the P1, it computes both packets, and it assumes that okay, packet is forwarded. So then it increments the packet forwarded plus 1. So direct trust will be computed by packet forwarded by packet sent. And recommendation credibility is the actual accuracy computation. So recommendation credibility is used to eliminate the malicious recommendations basically. So how we will compute the recommendations is, so for example A node is there, the B is there, and some X node is there. So what will happen is B sends the recommendations to A. So now A has recommendations of B on X, and A also has a personal direct interaction with X. So what it will do is it checks with its own direct trust to the recommendations, and it finds the RMS value. This is root mean square error, RMS error value. So it's based on RMS error value. So that means it will find how much deviation is there from one observations. Once it gets the difference value, we are computing one minus difference into Jacquard similarity. So this gives the recommendation credibility. So how xi and yi computes is, so if you see xi and yi table and the result if you see, so if both are 0, that means x says that is a malicious node and y says it is a malicious node, then the value of the result will be 1. If x says it is a malicious node but y sends a legitimate node, then the value will be 0. If x says good node, legitimate node, and y says malicious node, then the value will be 0. If both says this is a legitimate node, then the value will be 1. So like that we compute this xi or yi, and wherein is the number of recommendations in the table. So this gives the recommendation credibility. Here we have two mechanisms. One is which one is the one for both sets show similar neighbor behavior, and in some cases even though if both says similar behavior, but still we are saying it says a, because both are malicious nodes, which result is also 0. This is a proposed two mechanism, and the recommended credibility algorithm you can see just here. So this we compute as a RMS value. So like this all these things is the RMS error. So once we get the RMS error, that is 1 minus d into. So this is called the sim count. So based on the values, whether 1 or 2, we will compute this one. So indirect trust is computed based on the weighted average mechanism. So your recommendation credibility is the weight to the direct trust value, and this is the weighted average mechanism. So from this we will get the indirect trust value. So the computation is simple here. So whatever the recommendation we are getting for each and every recommendation, so if there is n recommendations are there, so for this n recommendation we will rotate, we will loop those n recommendations. So we will find out the numerator and denominator. Finally we will compute the indirect trust value. So this is the no trust value, where we average the direct trust value and indirect trust value. This is a weighted average. So here tau is the weight based on the application. We decides what is the tau value is. So once we compute the no trust value, the graph will be like this. So here A has a trust on B with 0.95, and A has trust on D with 0.91. Like that, the trust graph will be there. And if D is a malicious node, you can see A has a trust on 0.1, and this E has a 0.23 trust value. So this recommendation credibility also we computed. We compared with Pearson and cosine correlation, even though it's RMS also we have verified with our proposed algorithms. So if you see the first one, x and y, see all these are legitimate only in both sides, but still this Pearson showed very low value, but whatever our proposed model, it is showing the accurate value, because both have legitimate, so it should be high value. So as one value is reduced, so our proposed algorithm is also reducing based on the value, how much values it is reduced. So if more than one is reduced, still reducing it. So this is the actual behavior we have to show, that that is showing by the proposed algorithms. Here the interesting thing is, if you see this one, so if y has same values, so P is unable to calculate. If you see the cosine, it is giving high value. That means it is saying that x and y are similar to each other, but that is wrong. So whereas our proposed algorithm, it is showing that these are not similar to each other completely. So similarly, if some value is there, then also we are saying these are not similar to each other. So that is the actual result we need to get, and we are getting with the proposed algorithm. So this is the performance evaluation through simulations. So we have run the simulations with the constant bad recommendations. For example, if a node has a 0.9 legitimate node, so what malicious node will send is 0.1 always. Even though it is a legitimate node, it sends a recommendation as 0.1. So in that case also we are able to filter out the legitimate and malicious nodes easily. So with the dynamic bad recommendations also, that means if it has a 0.6, then we are saying within the malicious node will send 0.4 as a recommendations. So in that case also we are able to find the recommendation credibility value. So for legitimate node, recommendation credibility is higher, it's near to 1. For malicious node, it is near to 0. So we have also computed recommendation credibility based on the percentage of bad recommendations. So as the percentage of bad recommendations is increasing from that node, so the recommendation credibility value is going to 0 for both fixed feedback and random feedback. Random feedback is 1 minus of whatever value it is. So we have proposed a trust model here for IoT, so to mitigate packet dropping and Badmouthing attacks, and we have proposed a novel similarity model to distinguish between the malicious and legitimate nodes. So this novel mechanism is proposed to reduce the impact of bad recommendations in indirect trust computation. So the performance of the proposed model is presented here, and it is very effective to in computing the true set of trust values. And we have to implement the trust model on physical device to test to experiment and show the proposed model eliminates all the malicious content. And these are the references here, and thank you. We have presented this paper in World Forum of Internet of Things 2019 conference, which is held at Limerick, Ireland. So the paper title and the link is given below. If you want any further information, please read the paper. Thank you.